to talk about how to help you secure your cloud without falling into a money pit, or as I originally wanted to call this, how to spend $300,000 without trying. My name is AJ Kuftik. I'm a principal technologist and digital product strategist with Expedient. Today with me is Mike Garuccio, who's also a principal technologist. Hi, Mike. How are you doing today?
Pretty good, AJ. How about you?
I don't understand why that happened. Why my screen just went blue like that. I'm on a Mac. You can't blue screen back. I'm doing great. Hey, real quick housekeeping item. If you have any questions, please enter those into the Q&A panel. We'll answer those after the session. Maybe if you have a question, I happen to catch it, we might slide it in the middle of the presentation. If you ask a question, you're entered to win a prize. That prize this week is a $50 Amazon gift card. And this is all being recorded. You'll get a link to the recording afterwards in your email. It will also be available on our website, go.expedient.com/webinar replays, on youtube.com/expedient, instagram.com/_expedient, and linkedin.com/in/company/expedient. I always get those incorrect. Hey, everybody watching on LinkedIn, I hope that you found the link before I said it out loud. I appreciate everybody joining us today. We have a really great session. And for those of you who are new to Expedient, we've been doing this for about 20 years. We started with co-location. We've moved all the way through to cloud native. We've seen major transitions happen. And all along the way, we've had to kind of make changes to the way that we secure what we do. And so today I brought on Mike Garuccio, who is one of our principal technologists, to help us kind of talk through how we actually do these sorts of things, because I think it's really important that we have a better idea of how we actually make security happen in this new day and age. So Mike, as we've seen over the course of time with all of these various technology changes, with enterprise cloud and DR and cloud native and hyperscale clouds, what are the new challenges with security? Because I've secured my stuff so far. Why can't I just do what I do now?
So there's really a couple pieces there. The first is that you really no longer have a network perimeter. Most things that you're putting into the cloud are going to be exposed on a public IP address. And so you need to think more about securing things as if they're just sitting on the internet, as opposed to sitting behind your network perimeter. You technically can kind of obscure things like that in the cloud the way you used to, but then you're losing a lot of advantages of moving to a hyperscale cloud provider in terms of agility. So that's the first one, is thinking about how you work without a network perimeter. And the second is that, again, in order to take advantage of the cloud, the idea for most companies is to kind of push capabilities out from their core infrastructure and security teams onto people like their development teams. So now you're relying on everyone to be conscious of security instead of just a small group of people. So you really need to have tools that will let you know when there are problems or someone does something wrong, rather than just relying on everyone always doing things right.
Does that sort of play in? I believe that's usually called DevSecOps now, because people love to smash all these terms together. But from that sort of standpoint, how do we help developers consider the overall security of their application more than they did before? Because now they're writing the code to deploy the infrastructure too, which they've never really had to think about infrastructure level security before.
Really, the biggest thing there is to hook into their development processes so that you're deploying security as they're doing their work. So their developers typically are going to have their own CI/CD pipelines where tests are getting run, things are being processed as they're writing code. That's really where you want your primary security testing. But since they are going to have access probably beyond those systems, it's also important to have ongoing scanning in case someone goes in and makes a change directly on the server, or does things like creating an unsecured S3 bucket. So you do want to have ways of getting notified when things like that happen, or when there's drift in your configurations.
So how do I secure things across some of these clouds, right? Because I see a lot of customers and clients who want to go do things in AWS and Azure, and that's awesome, and we support that. We see customers who are coming to us to run their workloads. They have things that need to stay on-prem for latency reasons, or they wrote something very silly into their security audits and that sort of things and say they have to stay inside their four walls. So how do you secure across all of these things? Because they're not all the same, or are they?
Yeah, they're definitely not all the same. So really the thing that you're looking for is where you can inject commonality across those clouds and then where you can secure at that layer. So the two places that we've really seen success there are one, operating system level scanning, because that is something that is the same across all the clouds. Scan your configurations in each of those individual locations. And that gives you at least a pretty good assurance that no one has installed crazy packages, changed settings to where things are more open than you want them to be. And then the other place is utilizing a SIM that has the ability to collect log data and security data from all of those different sources, whether it be your endpoints out in the field, things like creating unauthenticated S3 buckets or bad firewall rules, breaches on servers. You want all of that data collected in one place so that you can then generate alerts out of it from that single location. Even better if it has built-in rules, so you don't need to be thinking about all of your different sources and everything that you might need to alert on.
And a SIM, for those out there, that's a security information and event management system. Think of it like a log collector, a syslog server, but that does way more than just collect your logs and present them to you. And I think that SIM is a massive change, especially one that can connect to a bunch of different locations. And so, how do I solve those security problems that I have today, right? We see a ton of things around ransomware. It's the hot topic now. But how do I secure those things today without ruining my future? You mentioned earlier around, oh, you can do all these things, but you will ruin all of the various benefits of going to a cloud. So how can I get the best of both worlds there?
It really is about maintaining that light touch. So finding the places where you can inject your security processes and scanning where they're not going to disrupt other people's work. You don't want to go to a development team and say, no, you may not do this. You want to take a collaborative approach with them and say, okay, I understand that you want to deploy your own servers in AWS. You have this great CD pipeline that's going to build things. Let's hook some security scanning automation into that process so you don't have to think about it. If something that you do causes it to fail, it's going to let you know, and then we can work together to resolve that. But it's not, you don't want to create any sort of manual gating processes or things that you have to do personally, because all that's going to end up doing is causing other teams to work around you and try and avoid the security policies instead of just working with you to make sure your network's secure.
So what you're saying is that if you do it the right way, everything will be nice and secure. And when you try to go around security, it's not going to end very well for you.
Yeah, exactly. It's not going to end very well. And then the flip side of that is security teams need to make sure that the path of least resistance is to work with them and not go around them. It should be easier to be secure than to avoid your processes.
And I think that doesn't have anything to do with technology, which I think is the very interesting part of all of this, is that none of this is technology based. It's not product based. It's not location based. It is all people and processes. And I think that we can kind of get lost in the technologies without really making these deeper changes to the way that we do things up front. So I appreciate the whole DevSecOps concept in terms of forcing people to look at the people and processes and how they're doing things. So how does one actually get started doing that? Where do you even start there?
I would say that the first place to start, if you don't already have it, is a SIM. Make sure that you're able to collect all of your data and alert on potential problems, because that's going to give you awareness, the ability to pick up issues as they arise. And if you ever are breached, is going to let you trace back what happened so that you can be sure that you've cleaned off that attacker from your network and not have to worry about them maintaining a backdoor or something like that. That's really number one. Next step after that is to start hooking into those development processes so that you're not catching problems after they happen, but before they happen.
So the other thing that I hear a lot is the whole reason the clients and customers and anybody else wants to go to an AWS or Azure is they see what Azure and AWS are doing. They see that they have some new technology. AWS has Watchtower or Guard Tower. I think I got it right the first time. But they have technologies to actually do all of these things native to AWS and native to Azure. So we hear a lot of customers who want to do that, but why would they not want to do that? Why would we recommend them not using those tools?
So those tools are great if everything that you care about exists in those environments, but that's pretty rare. Most customers that we deal with have on-prem, they have desktops and laptops out in the field that maybe aren't using VDI, so they're not able to collect logs and information from those. And the list goes on of places that you have data that's not in AWS or Azure. And so really you want something that sits outside of those and supports them very well, and can collect data from those sources, but can also collect them from your on-prem environment, your switches, your routers, your accounting team's laptops. You want to have that kind of full picture of what's happening on your network.
You got to know where all the cat memes are happening. I mean, that's really
exactly
what security is all about, is locating the cat memes and making sure that that the cat memes continue to flow. So how do you control these security policies going forward? Because we talked about how it needs to change. We're changing the way that people are doing things, but how do we build the guardrails, I guess is the better question there.
That's really about getting a lot of that data into that SIM and then generating rules based on it. So making sure that you're able to alert on things that are issues. So OpenS3 buckets is the one that we usually harp on because that's been the source of so many breaches. So you need to make sure that when someone deploys one of those, you're getting a notification and you can follow up and make sure that that really was intentional. Outside of that, you do want to make sure that you're also automating things like config drift checking. So if you have a policy that all servers should have their firewall on, you should have some sort of an automated process that's checking that on a daily basis and letting you know if, for whatever reason, that changes. Those two things together kind of give you that awareness and ability to follow up on things that have changed. And then the next step is hooking into, like I said, those CI/CD pipelines and doing things like when the developers deploy an image, scanning all of the dependencies that they have. So that way you're not introducing dependency errors or anything like that into your applications at runtime.
So let's take a step forward and say that somebody decides to migrate to AWS or Azure or GCP or even us. Mm-hmm. What happens if they don't do this? What happens if they end up without doing any sort of tooling? They're not pulling anything together. They're not seeing problems before they start. What could happen there?
It's really one of two things, and it depends in which direction they go with some other choices. Either A, they end up with a horribly insecure environment because they just kind of let everyone run wild and do whatever they want. And then you end up with some sort of a breach because someone made a mistake. And it's hard to even call it a mistake. It's just something that they weren't aware that they even needed to do because that's not their specialty. So they, went and deployed a server and just opened SSH to the internet and then set a moderately strong password. But if you have an AWS server, you're going to get hit for an SSH multiple times a second for all of time with people trying to brute force that. So easy mistake to make, also an easy way to end up with a breach. Or if you take the other route and say, all right, we're just going to copy and paste all of our on-prem security policies into this new world, you end up just spending a ton of money in the cloud and not getting any of the benefits that you were supposed to get from moving to the cloud. Everything still takes forever. You still don't get any agility gains. And instead of spending, one amount on your on-prem infrastructure, you're now spending 3 times that to be in the cloud and not getting any benefit out of it.
And I think that's the key, is that we want to make sure that we are balancing the new capabilities and these new functions against not spending a ton of money to do the same thing you're doing today, right? We want to focus on how can we actually get this very real benefit. I have seen in the past where people make their own mistakes and it leads to a different type of ransomware where some organization has now taken over and started to deploy a ton of crypto mining in your cloud. That's a real thing. If you deploy, and if you can do anything for me, if you take anything away from this, please keep your API keys away from GitHub. Everybody watches GitHub. They're waiting. They're looking. They know what to look for. They can search the whole thing. That's the whole point of GitHub. So please do not put any of your API keys on the internet, or else you will get your things taken for a ride and that money pit will get real big, real fast. So there's my pro tip from me to you. I've not done this. We actually had this happen at, I want to say it was a hackathon at some point in the past. I won't say where, but it was in San Francisco or Vegas. And anyways, somebody put their API keys in the wrong place and then it got taken for a ride. So all of these things are things that you need to think about. Because again, as Mike mentioned, is his very first point, consider that everything that you are building in a cloud is effectively sitting there with a public IP address. Everything is publicly accessible and you don't have a network perimeter. You do not have what I like to call candy bar security, very hard outside, very soft in the middle. So we want to make sure that we're considering all of our security processes. And that's a lot of where our security control platform comes in. We have our micro segmentation, we have multi-cloud firewall, we have our SIEM, as Mike mentioned a number of times. We have identity management and endpoint security to help you wrap security around all of your clouds. And along with that, have the ability to take that time, now that you're not spending it on building tools and getting it all set up, you can actually spend it on setting up those people and process changes that you need to be more successful going forward. And Mike, I think one of the other things is how do we actually automate configurations, right? You mentioned configuration drift. How do we actually automate the configuration in the first place so that you have something to check against for drift?
Yeah, absolutely. So there's a number of configuration management tools out there. Personally, I think that Ansible's kind of run away with that market at this point, but Chef and Puppet are also great options. So is the Salt Stack. But really the idea is you need to make sure that your configurations are automated and checked into source control somewhere so they're easy to update when you need to change them. That makes sure that anytime someone deploys a server, they're getting the correct configuration laid down and you're not relying on someone to follow your documentation exactly every time. And again, that's one of those things where improving security also improves everything else in the organization, because now all of your server deployments are automated. Someone needs a new server, it's a couple of clicks, and they have one that meets all of your standards. So again, the easiest path forward is the one that's secure. You're not relying on people to do hard work in order to keep you secure.
I like to refer to this as the baking of bread, right? There's a reason why bakeries can make 200 loaves of bread. Is because they have one recipe, and that one recipe is standardized and they know how to make it at scale, and they put out the same loaf of bread every single time. Versus me baking bread in my house, it will be slightly different every time because I don't control for all of those things. I'm still manually doing things and manually weighing things. So that's the sort of thing that I think, as you consider going forward from a security standpoint, here's how you can actually use this to not only improve your security, but improve your operations as well. And I think, as we go forward, thinking about your security at the application level. How do I secure the application? Because again, that candy bar security, very crunchy outside, has led a lot of people to be kind of soft with security in the middle. How do I connect my application, my database? How do I connect my application, my end users? How do we segment all of those out? So I think that's where a lot of concepts around microsegmentation, a lot of things that we're working on with microsegmentation come into play. How do you secure your things and make sure that your users aren't talking directly to your database server? How do you make sure that your applications aren't talking to the wrong database server, right? If this application gets breached, how do I make sure that this application can't talk to this database server and this database server and this database server all the way through? And you can minimize that damage. That's where a technology can come into play. But from a policy standpoint and from a process standpoint, this is where you actually have to consider, hey, should my application servers be able to talk to every database server? Probably not. It should only be able to talk to its own database server. That has nothing to do with technology and everything to do with process and people. And I think that's the bigger thing here. I see that there's a number of changes that have to happen as part of this. And as part of your cloud migration, this is something where Expedient as a whole, from a technology standpoint, can help so that you can focus on those people and process things. And Mike, I think as we go forward, what can we do as Expedient to help our customers move forward on this?
I kind of look to our role as an infrastructure provider, and I think the easiest place for us to do a lot of that work is by providing that basic security infrastructure. So you mentioned things like microsegmentation and really providing a platform in order to enable that, so that our clients don't have to think about how to enable Microseg. All they're thinking about is, what do I need to secure and what needs to talk to what? So we can make it very easy to figure those things out, and then for our clients to apply those policies. Same thing on our SIM platform. We can make it very easy to collect data from all of your sources. We can handle configuration there. And then our clients can think about purely, what policies do they need to put around that? What alerts do they need to put around that? And then potentially leverage some additional tools like machine learning, if they're interested in that, to give them anomaly detection for the things that they aren't even thinking about.
So if you would like to learn more, you need to do this part right like that. And hopefully it doesn't blue screen like that. I don't know why it does that. That's a new thing, PowerPoint. Great job. So what's next? You can go to our website at expedient.com/services/assessments, where you can download a free assessment tool to see your environment, to see it against all of the additional capabilities that AWS and Azure offer. See your environment and what it would look like price-wise, sizing-wise, and dependency-wise, to understand your environment and how you can migrate to the cloud right the first time. And you can even talk to people like Mike to dive deeper on your applications to see how those sorts of functions work. Mike has done a ton of these assessments. It's actually been a really great function of ours, because it helps customers understand where they're going, and there's nothing that you need to do to assist with that. You get to pick Mike's brain for a while. You can also go to expedient.com/services/multi-cloud, and you can see our entire multi-cloud vision, how we can help you cloud safer, smarter, and simplified, because those are the three things you need to do. And we've talked a lot about what we're doing as part of Cloud Safer, and we have a lot more to come on that. Now, Mike, next week, we actually get to see each other in person, which is really fun. But also, Mike, what are you doing next week at about 2 p.m.?
We're going to be rolling out our new ops control product, which takes care of a lot of those automation pieces that we talked about, configuration management. So it's really a centralized place for you or our customers to go ahead and deploy their workloads from, and then let Expedient take care of a lot of the ongoing management of those workloads. So allows you to offload patching to us, making sure that you have very, very solid monitoring. And also it's incredibly easy to then go ahead and incorporate those machines into our logging platforms, and will be available for our upcoming SIM platform in just a couple of months. It'll be very easy to get that integration pushed out as well.
This is
so that's next week.
Finished.
Oh, no, I was going to say, so yeah, that's our rollout next week is operations control, which is pretty much a management and monitoring offering that sits on top of your guest operating systems, both in Expedient's clouds, as well as in the hyperscale cloud or on-prem.
And honestly, for those of you who are new here, this is the value. This is the real value. I cannot wait. Mike's going to do a demo. I'm going to talk a lot about it. I'm super excited for next week to talk through this. Operations control is fantastic. And if you're an existing customer, we heard you, and we've got some cool things to show you. With that, I'm going to wrap it up here today. I want to thank everyone for joining us. Thank you for joining us this week. Be sure to join us next week. This is going to be super fun, and we will see you then. Thanks.